So this is basic derivatives, the chain rule, and this is a quick and easy method I'm going to show you. Most people do this already, and just about every teacher and lecturer accepts it, except unless they specifically ask for things like proper notation of either Leibniz or Lagrangian or even Newton's notation. So this will, unless they specifically ask for those, this will generally be accepted. And if you're doing this in your own time, by all means, it makes it quicker and easier. And it's not really a formula that you follow. Well, there is a formula, but it's more, you follow the formulas from all the notations because they're all the same, they're just written differently. But you just get rid of the notation, and that way you have a two-step process of the function, deriving the function, and simplifying the function. I'll show you what that is now. So let's start with a function. And then we know that from previous videos, or if you know the chain rule, if you're comfortable with it, this is a method good for you. You simply just derive the outside and leave the inside the same, and then multiply that by the derivative of the inside. So derive the outside, so you cover up the inside and derive the outside. You bring the 2 down and you multiply it by the invisible 1 that sits out the front. So that's 2x plus 1, because you leave the inside the same, and you take 1 off the power, so that's the power of 1. You can leave that out, be my guest. And then you multiply it by the derivative of the inside. In this case, the derivative in the inside is 1, because 1 goes to 0, and it's a number, and x to the power of 1 just becomes 1 when derived. So simplify it, it's just 2x plus 1. Now, to do an example, another example. Doesn't take up much room at all once you get good at it. If you're not quite comfortable with it, you can take longer, and you don't need notation, so it makes it easier to do it. If you're struggling with the notation part, you can do this and then get more comfortable with the notation by comparing by proper notation. So let's make an example. So here, derived right off the bat. So you derive the outside, 2, bring that down, makes it 8. Take 1 off the power, which would be 1. You leave the inside the same, then you multiply this by the derivative of the inside, this bit here. So you bring the 2 down to the 5. I have to have a bracket there. So bring the 2 down to the 5, 10, and have x to the power of 1, take 6. Bring the 1 down, take 1 off, ends up being 6. So then you simplify. You can simplify this by multiplying it in and out, but yeah, it's actually as simplified, really. You can go one step further, but I'm not going to. I'm just going to go on to another example. So what's this example 3? I'll have y x3 plus 2x2 plus 1 to the power of 5. Oh, I have an equal sign there. So when we derive this, we just, because there's an invisible 1 at the front, you just do the derivative of the outside, which would be bring the 5 down. 5 times 1 is 5. Leave the inside the same, Just like with every power rule, you take 1 off the power, which would be 4. And then you multiply this by the derivative of the inside, which would be 3x squared plus 4x power of 1, and then you would leave the 1 out because derivative of 1 is just 0. So you would go to simplify, which would be, you could multiply this by the 5, but you couldn't multiply this by the 5. Well, you couldn't bring the 5 in the brackets because it's the power of 4, but you can bring the 5 into these brackets because it's the power of 1. So that would be 15x squared plus 5 times 4 is 20x multiplied by x cubed plus 2x squared plus 1 to the power of 4. And that there is the first derivative of that. Okay, now, final example. Y equals 10. 4 plus x squared plus 3x. Now we know that equals 10, 4 plus x squared plus 3x to the power of a half. So, to the derivative of the outside, bring the half down to the 10. Half times 10 is 5. Leave the inside the same. And take 1 off the power. Half take 1 is negative a half. And then multiply this by the derivative of the inside. Derivative of 4 is 0. Derivative of x squared is 2x. Derivative plus the derivative of 3x, which is 3. Now, simplify this. This section, because it's to the power of a half, it goes under. This stays on the top of the fraction. That's 5 because it's, well, it's not, you're just multiplying it by this. It's not part of this. So you would have 5 over 4 plus x squared plus 3x to the power of a half. It becomes a positive now because it's on the bottom. And then you would multiply it by 2x plus 3. Or you could skip, because if you multiply it to the fraction, you would just bring it on the top. So you could skip this all together and bring it on the top. 2x plus 3. And you could simplify that further just by making it look neat with a square root, but I'm just going to leave it there. And that's it. Quick and easy method. Thank you.